This is the last talk today. It's about practical Tracewrangling. I don't know who's ever used Tracewrangler before, which is a tool I wrote. I'm going to talk about what you can do with it. Most people use it so far for sanitizing capture files, removing sensitive information, IP addresses, MAC addresses, payloads, stuff like this. But it can do a number of other things, and that is a fact that isn't that well known, so I thought I'd do a talk about this and also show you what the difference is between Wireshark and Tracewrangler, because they're quite different and they work together quite well, and I use them in combination quite a lot. So, backwards. I'm working for Airbus, the guys with the airplanes and stuff. Regarding the Wireshark community, I'm writing a blog. Some of you may have seen it before, even read it or commented on it. The blog is written in a way that it's some kind of reference and guide, and not so much about day-to-day whatever. It's more like showing techniques and tricks and stuff like this. I'm on Twitter if you want to see what I do. Q&A is the Wireshark.org question page. I already mentioned this morning. It's really helpful if you have something that you don't understand, or when you need help, or when you need to have an opinion on something. Usually people ask questions about how do I develop something for Wireshark, or how does the protocol decode work, or I'm having a problem understanding a trace file, and then you can ask there, and if somebody's interested in helping you, which usually is the case, that somebody will do that, you get answers and can discuss problems even in network analysis things. I'm at Sharkfest, quite obviously, because I'm standing right here, so that is the other thing I'm doing, and I created Tracewrangler. So the agenda is basically explaining what is Tracewrangler at all, what are the file and task concepts. I have a couple of ways of extracting packets. I will do demos because slides are boring, but I need to have some to explain a couple of things. And then there will be a roadmap, and the bad thing about the roadmap is it's quite the same that I already posted on Sharkfest US. Because right after Sharkfest US, I got into a project that overwhelmed me basically, and I had no time to work on Tracewrangler, so the roadmap is still the same. I couldn't improve on it. Okay, so what it does do is it is basically or mainly a trace file manipulation toolkit. So it's made in a way that it's helping you change trace files, extract stuff from it, remove something from it, modify packet layers. Sometimes there are packet layers that are totally annoying to you because you have a tool that doesn't understand what's going on. I had one guy at Sharkfest come to me and say, well, I have a Juniper firewall, and when I capture on that thing, it will have a Juniper protocol header in there before the Ethernet header. And that prevents this trace file from being worked on in various tools that do not know what this layer is, so you can't work with it. So what I put in Tracewrangler is a edit function where you can just say remove all those damn Juniper layers, and then you end up with the Ethernet header. There's a couple of them in there. Like you can remove CapWeb stuff, you can remove MPLS shims, you can remove GPS tunneling stuff. So if you want to get to the tunneled content of a transport tunnel, you can use Tracewrangler to detunnel the traffic and look at it in any tool that may not know how the tunneling works. So that is one of the ideas that I am doing here. If you have something else that you need as a modification, just let me know. I'm basically improving the kit or the tool whenever somebody has something that is a challenge or an interesting task, so I try to improve as much as I can. The main function that it is well known for is sanitization and anonymization. So my fellow presenters at Sharkfest are usually ones using it a lot, removing sensitive information from capture files they want to present. Very often that happens like the day before they have to do the presentation, and they come to me like, hey, help, something doesn't work, can you quickly do something? And giving me a hard time about it. Oh, there it is. Hey, well done. Now I don't have to scream that much. Sanitization and anonymization is something I will skip over for now, unless somebody's really interested in it, then we can do something as well. But I'll do that at the end. Layer removal manipulation, I mentioned that before. There's a ton of things that you can remove or manipulate if you want to. And what I'm going to focus on just now is flow extraction and packet extraction. So how do I get stuff out of a lot of trace files? You can do merging with it as well. The reason for that is that at some point the merge cap tool from Wireshark crashed when you tried to merge files with more than one interface in them. So if you had a pcap.ng file that had more than one capture interface in the trace file, you couldn't merge them. And that was annoying, so I added merging as a function to Tracewrangler. It is quite powerful because on merge you can say how the interfaces are supposed to be merged together. You can reduce them to just one interface, or keep all of them, or keep all interfaces from all subfiles. So depending on what you want to do, you can do a lot of different things with the merge. It runs on Windows and on Linux if you have Wine. The reason for that is this is written in Delphi VCL. I'm apparently the only one still using this thing. The reason for that is that it was the only language I knew how to use, and so the idea was either I learned for 5 years to do it in C and waste 5 years, or use the 5 years and produce something that everybody can use and get the blame from the Mac and the Linux guys. And I chose the latter option. It's open source though, so if you want to take it and create it and build it into something other thing, or into another language, be my guest. I only let you know that it's 200,000 lines of codes, so it's quite a task. It's built in a way that I don't use any kind of foreign libraries. I do everything myself: file reading, pattern parsing, packet parsing, dissection, reassembly. Everything is written by me, so no dependencies. Okay, so the question is, where's the difference between Wireshark and Tracewrangler? And let me go through this real quick because it's not that important. Wireshark has a gazillion of protocol dissectors. Tracewrangler knows about 34 protocols. The most important ones, obviously: Ethernet, IP, IPv6, ICMP, DHCP, that kind of stuff. And more will be added, of course. The display of decoded protocols is something only Wireshark does. I don't do it. I don't care. If you want to look at packets decoded, use Wireshark. That's not what Tracewrangler is good for. It can't even keep up with like 1/10 of the dissectors, so why would I even do that? So it's not what I'm aiming at. But the main thing is I can hold in my file list hundreds or even thousands of capture files. The biggest batch I had in there one time were 500 gigabytes. Processing them in one go. And the funny thing about that is that you can do all the processing that you do over all files in a batch. So load everything you have in there and let it process for you. And it can also extract stuff from all of them if you want to, and that's what I'm going to show. You have powerful filters in Wireshark. You have very basic filtering in Tracewrangler. It's only on IP addresses, ports, and some other minor things. So just the things that are really important. If you have fancy filterings, you need to do that in Wireshark. But my conversation statistics is a little more powerful than that in Wireshark, because my conversation statistics works over all files, not just the one that you loaded. So if you put 10 files in Tracewrangler, you can have the file statistics like conversations, endpoints, everything from all files combined, so that you see if a conversation TCP flow is spread across like 10 files, it will only show you one line for it and tell you it starts in this file at that packet and ends in that file at that packet. And you can extract it in one go and look at it. That's what I'm going to do in the demo. So Wireshark is not made for packet manipulation. You can edit some of it in the 1-point-something Wireshark version, but it's not really what it's made for. This thing is made for packet manipulation. And fully automatic packet manipulation means, for example, if you choose to remove like a VLAN tag from a packet, the problem is that the Ethernet header has a next protocol thing telling you, hey, the next thing that's up is VLAN tag. Then another VLAN tag. And then there's IPv4, like ether type 800. And what Tracewrangler does is it looks for the last VLAN tag, gets the ether type, moves it to the Ethernet header, removes the VLAN tags from it, and basically keeps the frame intact so that it still works. If you just cut away the bytes, it would fail because the Ethernet header would say, hey, next thing is VLAN and not IPv4. So the removal thing tries to keep the packets intact. Question? If you had a, okay, good. Looked like it a bit. Okay, so. Okay, that's good. Just if anybody has a question, just stop me or I keep talking. File and task concepts, I'll show in the demo anyway, so I'll go over it. In there, you will have file names without the path, because who needs paths anyway? You know where the files come from. If you click on them, you will see the paths. We have file size in byte, kilobyte, megabyte, or gigabyte, which is nice. File format, the file format of the files that you add is not determined by the extension, but by file magic. So if you drag a pcap file on it, which is called .pcapng, it will tell you, hey, this is a pcap file, not a pcapng file. So it looks at what the file really is, like Linux does. It will show you the first frame time, so it reads the first packet of the file and tells you this is the first packet in the file, and it will also sort the file list by that order. So if you drag 10 files on there and the last file is captured earlier than the first file, they will move or swap places. So the file list is always ordered by first frame time. So if you take a look at this, here you will see that this is earlier than that, earlier than that, earlier than that, and so on. Yeah, so it doesn't look at the file name, it sorts them by first frame time. There's a duration, there's a number of frames, and the status in the end tells you if something has happened or been done on the file. Okay. Adding files I will show, so let's go over that one. And now we'll look at extraction. Extraction is that you have big files, lots of files, tons of packets. You can't load them into Wireshark, or you don't want to. So you use Tracewrangler to find the things that interest you and extract them to look at them in Wireshark. That's what I do. So in most situations, that means extracting TCP sessions, because that's the most common thing that you want to do. And very often, like if you're having an IDS-IPS situation where you have a intrusion detection system telling me, hey, in this packet I found an attack, then you usually get only one packet, and the one packet is not really meaningful. And what you want is the full flow. So with Tracewrangler, you can easily extract the full flow for that one packet if you want to. That's one thing that I will also demonstrate how to do. Okay, I'll do this in the demo, so let's just go do the demo. All right. Okay. 22 minutes into the talk and the first demo. All right. By the way, if you want to use Tracewrangler, it's really easy to find. You just go to, you could even Google for Tracewrangler. I should be connected to my VPN, otherwise it won't work. Come on. It should be the first link because nobody else uses that name usually. So the page looks like crap. The reason for that is I didn't care, and I didn't put any advertisements and stuff like on there. Just give it a go and get whatever you need. I can recommend getting the semi-automated builds. That are the ones that are the latest features. It's not really stable sometimes, but very often it has less bugs than the latest stable version. So I usually work with the semi-automated build section. There's a source code in there. There's a documentation, which is kind of outdated a bit, but there's quite a lot of it. So you can look at it if you want to. And the other thing is, if you have anything you need or don't understand or whatever it is, just let me know. Contact me and I'll help you. Okay, I have a 32-bit version and a 64-bit version. I usually recommend 64 bits because if you're adding a lot of trace files, you need a lot of memory processing them. And then 64-bit can help. My machine at home has 64 gigabytes of RAM, and sometimes I use them all because I'm throwing in captures like crazy. Sometimes we have capture jobs we need to analyze that are in the terabyte range, and then memory helps. And the 32-bit version is limited to 4 gigabytes, basically. So, all right. Install is really simple. There's a zip file you'll get and extract the executable and run it. There's no installer, there's nothing, just the executable, which I really like. Let me show you how that looks like. There's a couple of other tools in there. I just made a Tracewrangler directory in my program files and put the contents of the zip in there. The Tracewrangler.exe, that's the main program. I wrote a couple of additional tools. ngconvert, I used to convert all sniffer traces to pcap-ng because Wireshark couldn't do it really well. And the one cool thing that I also wrote is pcap-touch. Pcap-touch is, if you know touch is a tool that programmers use to update the file timestamp on a source code file. pcap-touch opens a trace file, looks for the first frame, takes the time, and applies it to the file as the file time, which I use a lot because if you're working on an analysis jobs and you're extracting something, the extracted file will have the timestamp of the time where you extracted something. And when something tells you, hey, look at the frames starting at time whatever, you have to open them all to see where is the correct file. With pcap-touch, you can just resort them and force them to have the correct timestamp. That's something I can show later if you want to. All right, so this is how it looks like. You can't do much here because there's no files yet. So let me just add a couple of files so we can have some fun. And I usually use this file set here. These are about 2.4 gigabytes. What Tracewrangler does when you add files, it will scan the full file for conversations, IP addresses, all those things, and put them into a database. That database here is called .pcap-meta.db. The name is configurable. You can put whatever you like. It was called TraceIntel before, but I renamed it for my purposes to .pcap-meta.db. If you want to, you can use it in your own products or tools if you want, because it's nothing else than an SQLite database. So I write everything that I find into this SQLite database. For example, all the endpoints can be found here. So you have all the IP addresses, the frames received, the frames sent, everything, the first frame time, where it's found, the first frame nanoseconds, the TTL, if it was found in an IP address, in an IP layer or somewhere else. So everything that I extract will be put into this database. There are some people who use that database for their own stuff. So if you want to, just go ahead. TCP conversations, for example, will have also the same things. They will tell me if there's a SYN flag in there and the initial round trip time. All these things are kept in the database. The problem is, for the first time, when you add a file for the first time, you need to scan it first. I already did that, so it was really quick adding these 10 files because the database already knew each file and just loaded all the details from the database. If the database doesn't exist, we can try that. I move that file somewhere here, and I run another instance of Tracewrangler. And if I pull it down on the Tracewrangler form, you will see that it will now scan, and it will take longer, because now it's really scanning and writing the results to another database file in the end, which should appear on my desktop at some point. There it is. It was just created, so this is what the file contains. Yeah, so when you add a file for the first time, it needs to be scanned once. If you add it a second time or any other time, it will just read the results from the database, because PCAP files do not change. Right? Well, sometimes they do, but in most situations they don't. There's a couple of checks in Tracewrangler that check if the file has been changed. For example, it checks if the length is still the same, which works great for PCAP files. And it checks if the first frame timestamp is still the same. If the length and the first frame timestamp is still the same, I assume it's the same file. Yeah, for PCAP-ng, that doesn't work because PCAP-ng file size can change because it can add comments. And comments change the length of the file, so the length is not always the same. For that, I use the first and the last frame timestamp and check if they are the same. If they are the same like what I had in my database, I assume it's the same file. That's a trick I only can do with PCAP-ng because PCAP-ng files can be read backwards from the end to the beginning. You can't do that with PCAP files. That is because of the file structure. Yeah, PCAP files are not made for being read backwards. PCAP-ng is. Okay, so let's close that one. And now let's see what we can do. I can use a number of tasks here. Very often, as I already said, people will use the anonymization task where you can, for example, replace IP addresses, randomize them by subnet, by lists, by whatever. You can exclude a PIPA or documentation addresses. You can say, well, if an IP address is already private, do not touch it, or randomize it into another private range. Lots of features in there. But I'm not going to show that right now. We are going to use an extraction task. So if I extract from files, there's a couple of things I can do. I can use a flow filter to say I only want a specific combination of IP, port, whatever. But we're just going to do a very simple thing and say, well, just extract all the TCP flows that you find, and each flow should go into its own file, right? So what you should end up with is one file per TCP flow. And I'm doing that by creating an output file name that is made up of the source IP, source port, destination IP, destination port. So what Tracewrangler will do, it will read all the files in the file list, read every packet one by one, look at the IP addresses and the ports, create the file name that this packet needs to go into, checks if there is already a file. If there is a file, it will append it. Otherwise, it will create a new file and write the packet to that file. Okay? So since that will take quite a long time, let me reduce the number of files we have in there, because otherwise we're waiting like forever until it's extracted all the things. So let me just do this. I just say OK. Now here's the task, and I can click on Run. But before I do that, I go to the directory to show you there's nothing new right now, but as soon as I run this, there should be a directory called extracted. And in there, we expect files with the name of ipport.pcap-ng. OK? So cancel and run. And it crashes. Great, cool. Yeah. Yeah, maybe. Oh, I did. Yeah, right. I moved the file. Yes, you're right. Okay, that was trick 17 of hurting yourself, shooting yourself in the foot. Okay, let's do this again. Thanks for spotting that. I would have wondered what I did wrong. So again, extract, OK, show the folder, run it. And we get an extracted folder, and we will see files showing up.
A quick question.
Yeah.
So the file name really controls the grouping?
Yeah. So if you change the file naming, for example, you don't want every single TCP, but you want IP pairs, just remove the ports, and it will write that as IP pairs. Once you were first.
What happens if you have multiple conversations with the same parameters? Will they be put in the same file, or will it like file 1 or 2?
Yeah, what it does, it will look at the packet, get the information, build a file name, and check, does it exist? If so, append it. Yeah, so whatever you do, it depends on how the file name comes out. If you do something like, I don't think I have a parameter for sequence number in there, that would be kind of stupid, because then you could write a file per sequence number. I don't think that would be useful, but you could do that. There's a couple of parameters that we can use, and I'll show the list real quick again. I don't know how far we are right now. It's still taking a long time. But when it's done, we will get a list of PCAP files, and we can run Wireshark to look at any of them. And that's where the combination of Wireshark and Tracewrangler comes into play. You use both of them. You use Tracewrangler to extract the stuff you need, and then Wireshark to look at the thing. And we can check if there's just one conversation in here by opening the conversation statistics, and you see there's just this one TCP session. Yeah, so it extracted that one, and now you can work on it if you want to. Yeah, doing that with all conversations in a file is not that helpful, but for a demo, I tried to just show you that it could do that. So maybe I shouldn't use that big files or files as big. And now there's something that I forgot to add here. The abort button is not working right now for whatever reason, so I could let it run for quite some time, or I just kill it and be done with it, and we do something else. So, another run of Tracewrangler. Sure, you can.
Yeah.
Sorry, I totally forgot.
Yeah, I was, when you showed the trace right now, because since the file name is in one, I was thinking if it's, the trace would be just in one direction.
No, it's in both directions. Because it looks at, if you use the IP pairs, it would not make much sense to split them by source and destination. You always want two stations talk to each other. So I decided for you guys that you don't need to decide, that you don't need a parameter like IP source versus IP destination. I just assume if you want the source IP and the destination IP, that if they swap places, we still do it that way. So what it does, it finds both IP addresses, normalizes them by looking at which one is the lower. Usually one IP address is lower than the other, no matter what IP address you have. If they're the same, of course, there's no lower one, but then it doesn't matter, and it swaps them until the lower is the first one, and then I have a file name that is always the same, no matter if it's like this or like this. So that's how I write this kind of thing. Okay, your question?
Yeah, so with regard to removing the VLAN
Yeah.
layer, would it matter if some packets had the VLAN layer and other packets
No,
did not?
no, because it will check, do I have a VLAN layer?
Yeah.
So every packet that it reads will be dissected completely with all the protocols it knows, and then it's just checking, hey, do I have a VLAN tag? And if not, it will just pass the frame on to save time also. If there's a VLAN tag, it will check where is the last VLAN tag, because you can have Q and Q in whatever traffic. So it will find the last VLAN tag, check what the next offset is, then check where is the Ethernet header, where does it end, usually at offset 14, it's here. And then it will just remove all of this and keep, but before doing that, taking the last ether type, moving it into the Ethernet thing, basically building a new one from the information up there plus the ether type, and write that new frame completely. So it is rebuilt from scratch.
And adjusting CRCs as needed and all that.
And it adjusts all the CRCs, it does everything so that the frame looks like it had never had any kind of VLAN tags. Yeah.
Perfect, thank you.
Sure. Because we all have used tools that cannot deal with certain protocol layers, and it's totally annoying because you're stuck in like, this thing is really cool, but it doesn't know about VLAN tags. So what do I do? Well, throw in Tracewrangler and then feed it to something else. Okay, so just for the fun of it, I mean, I can crash it at any time, as you have already seen. I'll output something to a different kind of thing. Down here you can see the placeholders that you can use. You can use the file name, the timestamp, source MAC, destination MAC, VLAN IDs, source port, destination port. There's even a filter label, which is not clear right now what it is doing. It's clear to me, but not to you. I'll show it later. So these are all the things that you can use. if you find something that you want to have as a placeholder in the file name, which I can extract from the frame or otherwise, let me know, I'll put it in there. It's really easy for me to do this. Because this is basically just a string operation, replacement operation, before creating the file name. That is not taking any kind of extra work usually. So let's say we are just interested in two IPs talking to each other. So let's do this. I remove the source port and the destination port. Like this. Okay. And we run it. And now the files look like this. And now it's grouped by IP addresses. And we have less files, but more stuff in them, of course. Yeah, so really easy. By the way, there's a funny kind of thing going on between me and one of my colleagues, co-workers. He's always trying to show me that he can do all this with T-Shark as well. Most of the thing he can do, like the extraction thing, but the editing thing of removing layers, unfortunately, he can't do that. And even the T-Shark thing is working, but much more cumbersome because you need to fiddle with parameters and for loops and whatnot. And I try this to make it basically easy to use for anyone without having to spend half a day on figuring out what parameters you use for T-Shark. So this is trying to be as useful as possible without a high learning curve. Yeah. So let's stop it again. I should use smaller demo files. Come on, die. Thank you. All right. So, well, that is one thing that you could do with the extraction task. I'll show you a very cool thing now that I use most of the time. I don't often run these extraction tasks. They're okay and they're cool. But in this situation, maybe not that useful. Sometimes you want to use them if the files are smaller and you have a ton of them. But what I do a lot is using the files. Oh, by the way, if you want to move the files somewhere else, like to a different location, just move the database with them, and it will keep them like not, or will not try to reread all the files. It will just use the database again. So the database can be moved with the files and everything is fine. I even had one guy who asked me, like, can I do a scan with a database on a memory disk because I have my traces on read-only memory and I can't write the database to them. So I added an option in the preferences where you can say where you want the database to be. So you can put the database in a common path if you want to, and have all the data being written to a very fast disk or a RAM disk or whatever, or something that you wipe frequently. It's your choice. And you can also change the database name if you want to. Yeah, so it's all up to you. Okay, so what I do when I have a lot of trace files like this, I'm not using the extraction task, but I'm using the tools menu. There's something called communication details. And you can think of this of a combined conversation and endpoint statistics from Wireshark. You know both of them. The endpoint statistics showing you who's talking to whom, and the endpoints is what endpoints do I have, which IP addresses, and so on. All of that is in the communication details, and it looks like this. So the fun thing here is that if we look at the TCP conversation, you see it's 100,647 TCP conversations. And it will only have one entry per conversation found in all files. So if one starts in the first file and ends in the fifth file, there will be only one row telling you this many packets aggregated, this many bytes going back and forth. So it's like a conversation statistic over all files combined. And this is pulled from the database, obviously. So if you had files, they will be aggregated depending on what files are in the file list and shown. So I added a couple of things that are useful to me, which are not in the Wireshark conversation statistics. For example, the packet ratio. The packet ratio tells you who is sending how much bytes. So 22 to 78% means station or IP number A is sending 22% of all packets, and 78 is the number of packets from the other side. So if you have a conversation where only one side is sending and the other side is completely quiet, you can find that real easy by sorting on the column. And now you can see you have here something like 0%, 100%. Okay? 6 packets going from B to A, but nothing from A to B. And that is sometimes interesting because you're like, why is there only one direction? What is happening here? Right? So what I would do now is like, okay, show me this conversation, please. So let's go to the extraction task, right? No, just double click it. It's much easier. So I double click it, and Wireshark will open, and there they are. Yeah. So I can see here there's a sin, and I think you recognize the port number. 23. What is that? It's Telnet. Who uses Telnet? Well, obviously not that node. 81.209.17 something. It's one of my own servers. They don't run Telnet. But idiots from China, Russia, and whatever, they always keep trying, like, maybe he has Telnet running. Maybe he has Telnet running. They don't get past my firewall, which is you only see the SYNs, but nothing else, because the firewall's like, no. You don't get in here. Yeah. So stuff like this is really easy. We can check other things. For example, the other column that is really interesting is initial round-trip time. Everybody know what initial round-trip time is? It tells you how long it took for the SYN-ACK, like this rear handshake, to be finished. And you want it to be real fast, because that means we can talk real fast, sending packets back and forth. So guess what? You can also sort it and look for initial round-trip times that are interesting. Well, if I'm going up, you will see that I sorted it by worst to best. And now I have an initial round-trip time of 71 seconds. Congratulations, that is not fast. That is real slow. So we want to know what that one is. And if I double-click it, it will extract this. And the trick by this, and that's why it's really fast, even with a lot of files that you have added, in my database, I know in which file the first packet is of that conversation. I know that because I scanned it. I know at which offset it is. And I know where the last packet is. So if I have 500 files and I click on something that is in file 203 to 205, I will only open 203 at that first offset and read until I reach the last offset where the last packet is and stop, because I don't need to read all the 500 files. I know where it is.
You do that before you give it more.
Yeah, exactly. So if I double-click this one, you will notice maybe that on the bottom where you can see select rows just on top of my Windows logo, there will be a short percentage counter telling you extraction is percentage 1 to 100%. Usually it's really fast, so let's try that. It says status extraction file 100% complete, and now it's only starting up Wireshark.
And we could save this as a
Yeah.
Wireshark, save it as
Yeah, save it as something. The problem right now is that I extract to a temporary file on disk. So if you don't save it somewhere else and do another extraction, you will overwrite the one that you already have. That is a problem. What I want to do is pipe my result into Wireshark so that Wireshark knows that this is ephemeral and not saved yet. Then it will warn you that you need to save it first. But I haven't figured that one out. I need to talk to the Windows developer guys. So this is the one with the really bad initial round-trip time. Let's check it out just for the fun of it. Well, it said there's an initial round-trip time of, what did it say? 71 something, 71.9. Must be here somewhere. It's probably this one. You can see there's a SYN-ACK. So somebody talked to my server and said, hello, I want to talk to you. And my server tries to say hello back. And the third ACK isn't coming back until number 10. And if you want to, you can check if I'm right, but I've done that so many times by now, checking my own code to see if I'm correct with my calculations. So far, they are all correct, so I've given up calculating them. But if you want to check my results, go ahead and let me know if you find a problem, because then I can fix it. So this is a conversation where the initial round trip time is really bad, and if you happen to have geo-IP on your Wireshark installation, then you can see that the source is coming from something called Telefonica Germany. And Telefonica Germany is a provider for cell phones. So sometimes you have people using a cell phone to access your websites, and they're in an area of really bad reception. So what you're sending them may not reach their mobile device. And all the things I checked where the initial round trip time is really bad, like above a second, they're all cell phones. Yeah, and you can quickly find them by that kind of method, just sorting by initial round trip time. Number 10, I think. It shouldn't, because it is the third ACK, but it does, yeah. Yeah, it has a payload. So maybe it's one ACK before that, and the calculation is off by one packet. I need to check. All right. So this is easy for me to find because I used the same files again, sort them by initial round trip time, click on the first one, and then I can check if I was correct or not. But this is really like looking crazy. I mean, the fin is before the handshake is finished and stuff like that, so it's really weird. Okay, but this basically is the same result as if you would have filtered everything from in Wireshark itself, going through all the files and extracting it. So the packets are all the same. Yeah, it's just a quicker way of getting there. Okay. What else do we have? Oh, I think I closed the conversation statistic. Yeah, I added a flags column so you can see which kind of flags you found for the conversation. Sometimes that is interesting because you only see SYN flags for a conversation or reset or whatever. That's nothing special. And the last thing here is the status column. The status column is telling you a little bit what the problems are or what unusual things it found. For example, it says handshake and teardown if there is a three-way handshake and a fin-ack teardown or a reset at the end. If something goes wrong, it will tell that too. And for example, this one says handshake and teardown after multi-SYN retry, which means somebody tried a couple of times to talk to the other guy, and it only worked after a few tries. Yeah, so SYN, SYN-ack, SYN, SYN-ack, ack, SYN-ack, SYN-ack, and then, so this is another thing, even if the initial round trip time isn't that bad, it will let you know that here was a handshake that had some problems in the beginning. Okay? And you can also have other things in there where we only see, let's see what else we have. If I want to find something like this, I can also filter, and that is a text filter. So you can type in parts of an IP address, part of a port, part of a message. So let's say SYN retry. And then I will only see all the things where SYN retry is in one of the messages. So let's see. These are all the things where it said that there's something wrong. Let's look for SYN instead. Here's SYN rejected. SYN rejected usually means there's a SYN reset kind of thing. Yeah, so something like this, SYN, SYN-ack, reset. Don't ask me why, but it's doing a reset instead of an ACK. So, huh? It's just a silly client. Yeah, I've no idea what it's doing, but.
Can you detect duplicate packets by the IP ID number and get rid of them?
Not in this build. I have another source code built where, and this expert kind of thing that is filling this column is really a very simple one. It's really bad. Very often it's wrong. So you're looking at it and you're like, what are you talking about? I built a much more powerful one, which I call right now TCP Investigator. That one will even see duplicates and remove them from the equation. So if you see a duplicate, it will determine if that is a true duplicate by IP ID, by other things, and not consider it in that way. So that one I'm still working on, but I don't know when I'll be finished with it. If you want to, I can show you TCP Investigator a little later. It's a work in progress kind of thing, which got sidetracked by my boss dumping tons of projects on me. So I don't have that much time to program at the moment. Okay, so that was, question. Yeah, multiple captures, yes. They're from the same capture point, yes. Very often what you do, or what I do, is somebody tells me, hey, we have a problem with this server. Can you capture it and see if the problem appears? Yeah, or the last big job I had was somebody telling me, hey, capture somewhere in our network and tell me what problems you can find. As a network analyst, that is like, really? Because no indicators what you're looking for. Usually you get a problem description, right? And somebody tells you, hey, this server is having a problem at that time, or not even that time, but with that protocol. That was a job where somebody said, hey, here's a week, capture something, tell me what the problems are. So I used that a lot, just showing me all the weird kind of things. And then I captured in a ring buffer, I think thousands of files, just for a couple of days. Then I collected them all and worked through them. And you can't do that in Wireshark. It's impossible. It's just too much.
Can you do multiple captures?
Looking at multiple captures from various locations and relate them? No. No. That is the typical question of, can you do a multi-point capture and show me where the packets take over and get lost and stuff like that? No, that is why you need to buy something like Packet Analyzer and other tools that can do that. Yeah, so that I haven't done that yet. There are so many things I still want to do, but somehow I have 24 hours a day. I don't know. Yeah.
Can we use it to detect the chatty traffic?
Yeah, you can use it to detect chatty traffic.
There's notion of a turn rate or something like that?
There's what?
The turn rate. It's possible to...
It doesn't do any kind of graphs, but you can sort by the most bytes sent and that things, yes. Yeah, if you want to, you can, for example, look at which IP is doing the most traffic. For example, if you go to the IP list here, and I need to clear my filter because there's no SYN in the IPs, I could basically just go and say, okay, who's doing the most bytes? This one. Yeah, so things like that you could do. But when people come to me and say, I need to do some sort of who's doing the most whatever, I usually point you to a NetFlow-oriented solution because that makes much more sense than capturing tons of packets. Yeah, because that eats disk space and, yeah.
Is there like an ODBC driver for Excel to talk to SQLite?
I'm not sure, probably. I wouldn't be surprised if there's some Excel connectivity to that database.
Okay, but otherwise you're using the SQLite manager?
No, it's just a connector directly from my program to a SQLite database. There's nothing in between.
Okay.
Yeah.
Is there another external tool to process the database?
Tons of them. SQLite is like the single access file database ever. So if you look for that, you will find so many tools, you will have problems decide which one you want to go for.
And all the schemas in there?
Everything, yeah. What I'm using here and what I used to show it to you is just a Firefox plugin, because even Firefox is saving all its data in SQLite databases. So you can use whatever you want. It's really easy. And if you want to, and if you need the results from this here, you can also go and say, well, export all to CSV and get it from there. But that will give you the combined export from this view. If you want to look at the database, which has more information, then you need to connect to the database directly. Oh, by the way, I forgot something that is really nice. You can, if you want to, change the TCP view to a per IP pair view. When you want to see all the TCP connections between two pairs, you can do that by right-clicking and say, View, toggle aggregated mode. And if I do that, the view will change a bit. And now I can see which IP pairs have which connections. You can see here, this one, they have like 2 connections. These 2 have quite a lot. So if you want to, you can aggregate all the TCP connections by IP pairs. Sometimes that is helpful because you only want to look at 2 IPs talking to each other. That is the aggregated view. And then there's a feature that I used to track down a problem with a proxy, but I'm not sure if it's really useful to anybody else. And that is called the highlight mode. Let's check it out. You see everything is gray. Let's click on something. And the highlight mode means I select a conversation, any kind of TCP connection, and all the communications that start after this selected communication started, but ended before it ended, will be shown. Everything else will be grayed out. So with this, I can see all the communications that started after the selected communication and ended before it ended. Very often, if you're looking at a proxy, you're talking to the proxy and say, hey, give me this. And then the proxy makes its own connection and fetches something and is done before it returns it to you. And with this, I select the original connection that I'm sending to the proxy. And with this thing, I can see everything the proxy does just before it's finished with me. So that's what I used it for. So if we scroll down far enough, we should see at some point that things will get gray again. Oh, I think I got one that is really long. All right, let's see. Yeah, now it's gray because these are all connections that are starting after my selected communication ended. So highlight mode means show me everything that is within the time frame of my first and last frame of the selected connection. It's a quite special use case, but maybe somebody can use it as well. As you can see, I'm using Tracewrangling a lot to do stuff that I need. And if you need it too, go ahead. So what else do I have?
Are you also tracking non-TCP?
Yeah. There's UDP, for example. And I mean, basically, I have UDP, TCP, IPv6, IPv4, MAC addresses, and all the addresses itself. The one thing I'm working on, which I have in a developer build, is also name resolution, so that you can see all the FQDNs that you have in a tree view that is folded out by basically domain name. So you will have like a .com, and under there you will have .riverbed, .wireshark, .whatever, and under that you will have the www, stuff like this. It's not working that well yet, but it will be there. Because that is a security feature or something that you can use a lot for security-related tasks. That will be to the right of the UDP conversations. By the way, extracting UDP conversations, what you can do here is if you don't want to extract just one conversation, and that is basically the same for UDP and TCP and all the others, you can select more than one and just say extract to a single file containing all the rows or to multiple files. So again, you have the option of selecting a file name like this, and you can only extract those that you really want instead of all the things that you just saw in the extract task thing. So removing stuff or extracting stuff from a ton of trace files is really simple. All right? Okay, so good. I think I'm close to having to finish. Well, as you can see, I'm using that thing a lot because it helps me navigate real quickly through tons and tons of packets. Loading all of that into Wireshark would take ages, if not days. And with this, it's just done. Yeah, that is really what I'm using it for.
A quick question, can you change payload? Like if you wanted to get rid of...
Yeah, that is what you do in anonymization. So if you have anonymization, the first and most important thing is this one, remove all unknown layers. That means for not exposing anything Tracewrangler doesn't know what it is, this needs to be checked. So that means if it finds a protocol like right now HTTP, which is not a good thing, but right now it doesn't know how to process HTTP. If it would find HTTP, it will just cut it away completely and drop it. It won't survive. If you want it to survive, remove the checkmark. Then it will stay in there. Sometimes people will only want to change the IP addresses and not the payload. If you want to remove it and say, but I want to remove it and replace it with 0 bytes, you can do that, or with a pattern also. If you want the frames to stay the same length, then you can do that.
And then you can change strings to certain promise to replace strings.
Yeah. That is something where you need to uncheck this, because otherwise it doesn't make any kind of sense. But then you can say, well, replace the original, come on, I think I have to, whatever, with something. So the interesting thing is I have a delta column telling you that there's a length difference. You should not replace something with a length difference, because sequence number will explode and hurt you so bad that you throw away the trace file afterwards. If you're now wondering why, try it and you will see why. If you are really willing to do that, just checkmark this, do not enforce same length, then it will allow you to replace with different lengths, even shorter or longer. If this is not checked, which is the default, it will force your replacement to be this exact same length by either cutting your replacement string or by padding it with zeros. Yes?
Could you make something so that you can replace hex values?
You can do that already. Just put whatever you want to replace as hex into...
That's all strings, so I thought, wow, that's...
No, you can replace whatever you want. Just if you have, for example, let's say 2F or 2D, put it in this pipe things, and that is basically just like in Snort, in the Snort syntax. You can replace any byte pattern that you want. You can even mix it with strings and whatever you want. Yeah, it's just a lot of work to do that sometimes, but you can do it if you want to. Okay. Yeah, usually, I mean, this thing is used by many of the Wireshark presenters just to get rid of IP addresses, payloads. If Hansang is showing something like, hey, this IP thing is, or this TCP conversation is doing crazy stuff, he just runs it through it and has a clean trace afterwards. There's a Hansang feature in there, which is this one here. No, where is it? There it is. Auto mode. Auto mode means if you add a trace file that only has 2 IP addresses in them with one single TCP connection talking to each other, which is a typical demo case. You have one TCP connection that you want to show. It will automatically replace the client with a 192.168 IP and the server is a 10.something IP, which is what he likes. And if they both are in the same subnet, it will replace both with 192.168 something. It's just to make it quicker and easier and not fiddling around with too many things. If you want to replace stuff by hand, you can do, for example, a lookup. Once again, it uses the database, because in the database are all the IP addresses. So you can just say, hey, this one, replace it with, okay, and it will do that. And it works in a way that the more specific your replacement rule is, the earlier it gets used. So if I replace an IP by another IP, then it will do that. If it doesn't find an IP that it sees in a trace in that list, it will do something else. For example, replace by subnet, if that's active, or otherwise randomize. So you can choose what you want to do. Okay, what else? Yeah, well, let's just say I show you quickly the PCAP touch thing. So if I have a trace file like this, and we can stop it right here, I don't need it completely. Let's say I take any kind of connection. And you can see how long it takes Wireshark just to isolate one conversation. Of course, it's a little bit unfair because I got my database. So if I save this thing to a new file, usually I call my directory extracted and say something pcap ng. I don't need to add the extension, but let's do it. So you can see that this now has a timestamp of the 8th of November in German format. So with PCAP touch, I can just go in there and say, oh, that's the wrong one, I think. Let's use this one, much better. Oh. There it is, and now I say PCAP touch star, and you'll see now it has the 6th of July 2014. Yeah, it is capable of using wildcards. You can do it recursive if you want to. You can also tell it to fix the extension. So if it's a pcapng file, but it's called .pcap, it will also fix the extension for you. So basically a little helper tool that is really useful. And it is in the zip file from Tracewrangler. So if you download Tracewrangler, you get this automatically as well. I run this all the time. Like whenever I'm extracting something by hand, I always run pcap touch on them files so that the timestamps are again in the time range that I need, because a lot of times we're talking among each other about, hey, this happened at that time, at that day, and if the file timestamp is not correct, then you're searching all the time for it. So that's what I do. All right. Yeah, in the end, real quick, let's go back to the slides. Do the roadmap. There was somebody who asked me, like, can we adjust timestamps? Because somebody said, well, sometimes if you have an incident like Saudi Aramco or something, if you get traces from the exact time that everybody knows this happens, even the timestamp can be a problem. So I want to be able to change the time. And that means I also need to change the NTP timestamps because I want them to be in line with the frame time. So I can read NTP right now. I cannot write it yet, but it's not that complicated, so I didn't have time for that. I need to add more protocols, especially DNS. DNS is the blocker for everything else because until you have FQDNs that you can replace, nothing of the high-level protocols will ever be sanitized correctly, because HTTP, FTP, everything has like www something in there, and you need to have a way to replace the DNS stuff first, and then you can continue. DNS is a little nightmare because of the compression feature it uses to compress various records into one by having pointers in the packet. So it's really not that easy to build it up again if you parse it. I can parse it, but not build it at this time. My loader is limited to 2 gigabytes because I'm using a special Windows method of reading the file in the fastest way possible, but I didn't put in the additional offset moving kind of thing that I need to read more than 2 gigabytes, so I need to do that. I need to add loading ERF files, which is the file format from Endace. They write their files in that format, and it's a streaming format which is really fast, so I want to be able to read it. Then the biggest thing of them all is implementing TCP reassembly. TCP reassembly is a nightmare on a different level because you can have retransmission, you can have missing packets, and you need to find a way to deal with them. And by requests from multiple persons, I need to create a CLI version because, for example, there's a tool called Workbench by Paul Offord and his team that you can download freely, which is like a workflow process tool for packet analysis. Paul is here at SharkFest. I haven't seen him yet, but he has a talk tomorrow or Friday. And they are using Tracewrangler to anonymize, for example, results that they're giving you. And they have a bit of trouble with calling another GUI tool from their GUI tool. And the CLI version would be much nicer. I'm working on that as well. And a CLI version is also something that may be possible to port over to macOS and Linux. These are the reasons why I want to do it, but it takes some time because you have seen the anonymization parameter dialog. All of that needs to be converted to a parameter file thing that is useful. So that is boring work and totally annoying, but I have to do it. So it's a slow process, and that's about it. So use it. Let me know if you have anything else that you want to use. If you're interested in the editing feature, just look at it. You will see there's a ton of protocols that you can remove. If you have any protocols that you need removed that I don't remove yet, I need just a PCAP file to implement it, and then I can put it in for you if you want. So if you have any other features that you would like, that you think are useful, just let me know. The other presenters do it quite a lot. By now I know most of the things they want to do, so it's possible that I tell you, yeah, it's on my list already. But I work on requests for this kind of thing whenever I have the time. So thank you, and have fun with it.